All right, so I have a notebook here that's a Colab notebook. And the reason I like Colab so much is that it's really great for doing demos, is reproducible. So it's kind of has a DevOps flavor to it, right? And in particular with Colab, I have the Colab Pro. And one of the cool things about this is if I go to connect here, I can go ahead and tweak things, right? So I can actually go to a connected hosted runtime. I can even connect to the Google Cloud. I can connect to a local runtime. And I also, if I go here to change runtime type, I can actually even add a very powerful GPU that I believe I get access to for close to 24 hours. So it's a really cool environment that's available. As well with Colab, if we go here, notice this table of contents, we have this huge window of things. Like I have a lot of code in here that I don't have to actually hunt and search for. It's just readily available. So I'm going to go through here and do a quick tutorial on some of the basics of Python that I think are helpful. And so to start with, I would say, we already went through Colab, went through some of the details. I would say probably the next thing to be aware of is the introductory concepts of Python. We have procedural statements, we have strings and string formatting, we have numbers and arithmetic operations, and we have data structures. And so with a procedural statement, this is something that happens all the time. It's just you're telling the computer what to do, right? We can say print hello world, right? That's one of the easiest ways to do things. In the case of a variable, you just assign it like a string right here. If you want to do multiple things, procedural statements, it's just one after the other. If you want to go through and add numbers, it's just like a calculator. There's really not much to do. You can also add strings together, right? And now we're getting into things that are more like programming, in that, if I wanted to put a collection here of, belts, white belt, blue belt, purple belt, brown belt, black belt, and I want to loop through it, I can create a for loop. And this loop variable here, belt, gets swapped out every time it goes through the list. And that's it in a nutshell, how looping works. And if I want to put a condition, if I say, look, if the word black appears, which won't appear towards the end, then print this out. Otherwise, print this other statement. If you see here, it prints out. So that's really programming in a nutshell. And then if we want to look at strings, you can see with Python a ton of different strings that you can do. You can split strings, you can capitalize strings, you can check if they're numeric, right? There's a ton of things you can do with strings. And I would say in general, though, the number one thing I would mention about strings is use f strings. In this case, I think I just have to assign this variable, which is up here. There we go, basic string. And if I go down here, we can just do this basic string, right? You just swap out a variable inside of here. And obviously I could have just done this. It would have been easier to just go like fruit equal to apple, and then below this say, I love this, and then put in the word, the variable. Pretty simple. Triple quotes come up a lot as well with Python. You can just put a phrase inside. If you want to replace it, you could just do a dot replace at the end. This is pretty common. And again, we've kind of talked over numbers. I would say lists and dictionaries are a little bit more important, so we'll spend a little bit more time on this. This is where you would store the data structures. And in particular, how do you build a dictionary? Well, right here, it's just a key and a value. In this case, I put in a string. Note that you can't put something that changes inside as a key, because the way dictionaries work is that they have O to the 1 lookup or fast lookup. And so you can't have something that changes, or else the whole algorithm wouldn't work anymore. And in this case, if I put in key value, key value, key value, you can see I can print out that dictionary. So pretty easy to create a dictionary. And you can also create it a second way by just using the built-in dict function. And in this case, you would just put in the upper body as the variable and lower body. So depending on what you're doing, this could also be slightly easier to create things. And if I want to use the dictionary, the best way to do it, the most intuitive for most people would be to pull the key out and to pull the value out and loop through, right? In this case, that's what I do. I pull the key, I pull the value, and I loop through. Now, if you want to throw something away in a for loop, this is kind of neat to know, is you just put an underscore like that, and I would just go for underscore, so throw away the key, but keep the value, and you can say the dictionary.items, and it'll just print that out. You can also filter by, again, putting a conditional statement like if body part is equal lower body part, and it only prints out the statements that match whatever it is you're doing. If you want to go through and do the keys and values, here we go. These are the keys. These are the values. Pretty easy. One of the most powerful ways to use a dictionary, that's the O to the one lookup time, so it's always going to be super fast, or fixed time, even if you have a million items, is you just say if this key exists, show me. And you can do a timing on that as well. Now, the lists are the second thing that come up all the time, and you can see here you just put things inside. So I think of it as like a shopping basket, like that you carry in the grocery store. Like you put stuff in your basket. You can also programmatically hold it right here, right, with list, and you can just start appending things. You'll see this a lot when you're programmatically building a list, is you say dot append and let's say a for loop. Now, another thing you can do with a list is use something called a list comprehension, and it's basically a backwards for loop. So you would say, for guard in guards.split, and then you put in the bottom right there. So it's kind of like it's twisted a little bit. And the reason people do this is it gives you C-level performance at looping. So looping is very computationally expensive. So if you did have to do something that was really, really loop intensive, like for 1 million items or something, then the list comprehension would be great because it would massively speed up your Python code. So that's the key takeaway. And as well, you can loop just like we did with dictionaries, do the if statement. The one big difference between a dictionary and a list is that you can slice, right? So I can say, I want to get the first position, I want to get the last position, I want to get the first 3 positions. And it's just literally taking the numbers and selecting what section, either the very end, the very beginning, or some segment of it, and pulling it out. Another thing you can do with a list is you can have a list of lists, which is building a matrix. And what's cool is that, you're building like a Rubik's Cube. You can just rotate the Rubik's Cube, and then you can make it another shape. In this case, if you use zip, that's what it does, right? We had this and it just rotates it at an angle. The final data structure I'll talk about is sets. And those are kind of cool because if you ever need to like deduplicate something, a set is a great way to do it. Notice here I put the same word in 3 times, and then I put another word in, another word in. Look, it just makes it unique, right? And so that alone is probably a good use case for sets. And you can also find the differences between 2 sets, like let's build a set here, and then let's subtract from the other one. So that's, I would say, the super, super high level, takeaway for the syntax of Python. What if we want to get into more DevOpsy kinds of things? Well, what we should do is get into things that are more common to do. And I think in particular, I think with DevOps, some of the things that are important to talk about would be the file system. And so let's go ahead and dive into automating the file system. So it's very common as a DevOps engineer in particular to need to talk to a YAML file or CSV file, etc. Now in Python, the way you do this is that you would go through here and say, open a file, write a file. And in this case, I have to make it writable. The problem is I have to remember to say f.close or close the file. And this makes the code a little bit brittle. Now, if I want to even loop through a list right here, right, we can do the same thing, but I still have to do this f.close. And so there's a better way to do it in Python. The way to write elegant code in Python is to use something called a context. And so the way this works is if you use the with keyword and you say with open, it'll make it writable. And then in this case, we just have 2 lines of code to write something to a file. And so this is definitely the way to go when you're writing a file. What about reading a file in? So we have the same problem, right, with reading a file in, is that, I can't, I have to do close. What do I do? So you do a read a file in with a context as well. And so in this particular scenario, I would go through here and build out a context. Now, in terms of serializing data, this comes up a lot. And in particular, the scenario would be that, let's say that you're needing to write something that you put into a dictionary because you don't yet have security clearance to talk to the database. Well, you could just save it to disk as a pickle file temporarily. And so here's a dictionary. I would just put a couple things in there, import pickle, say pickle.dump. And in this case, here we go. We've got a pickle file. If I want to go ahead and load it, here we go. We've got a file loaded, and then I can actually go ahead and print out the result. So pickle is a great tool to use to just go back and forth between Python. The other thing you can do, you don't have to use pickle though, you can use a more universal format like JSON, especially you're working with Node, Python, Ruby, Java, C#, whatever. Everybody's using different languages. Well, you could serialize things out as JSON, JavaScript object notation. And this is a great idea. So in this case, if I say import JSON, I would say open data.json w and write this out. Also cat a file here, also load it back in with the with statement. And you can see that a JSON data structure is pretty amazing because it's actually got some of the same utility as like a pickle, but other people can use it. And it's the data structure that you're probably going to use when you build out a microservice. So I find myself using this style quite a bit. Another one that comes up quite a bit for DevOps engineers is YAML. Almost everything is YAML. So in the case of a build system config file, it's probably YAML. So how do you do that? Well, if I just go through here and I say import YAML and I say with open data.yaml like this, we can save this out to disk. And then you can again see here that I can actually show the results. So if I want to load the YAML, also very straightforward, just a couple lines of code. I would just say with open data.yaml and then load it up and then print it out here. Right, so very, very good techniques. I would say JSON and YAML are probably the ones that for data science or DevOps, most people should probably focus on. Okay, let's move on to managing files and directories using tools, high-level tools. In Python, the oldest tool that a lot of people have had experience with is something called os.path. It's been around forever. That lets you walk through a file system, those kinds of things. Pathlib, which is different, is a unified interface for dealing with the file system. So it's kind of like a Swiss Army knife. And I'm going to go through how to use Pathlib here to do a bunch of different things that are common operations in Python. So to start with, what we can do is import pathlib, and I can say make a directory, right? So basically pathlib.path, I put in some path, and I say make the parents as well. If it exists, okay, it's true. So what this means is it's idempotent, right? A good DevOps term. So I can just run it over and over again, and I always get the same result, which is that this directory, in fact, does exist. And now, if I want to go ahead and create a couple more directories, how do I do this? I can just say pathlib.path and make a couple other directories, right? So very easy tool to create idempotent directories. What about if a path exists, right? I can say pathvar.exists and it'll show me whether it exists. In this case, this one does exist. So in this case, pathvar 2 exists, the pathvar 1 doesn't. And then if I want to say pathvar.write foo, here we go. I can actually write even text into a file using the same path var or the pathlib. So it's a really powerful tool here that allows me to deal with this. So one of the things that we could do, for example, is if I wanted to rename a bunch of files with pathlib, I could say from pathlib import path, go ahead and create a directory, write some stuff to it, and then we'll print the stuff before it's renamed. We'll then rename it, right? Because I make another instance of it, and then we verify that it's renamed. How does this work? There we go, right? We can see here's before rename, here's after rename. So you can see that, like, if you were going to do a bunch of automation to the file system, like rename directories, move them around, all this kind of stuff, create directories, pathlib is probably the most efficient way you could possibly do that in Python. There's other things that you can do to search. A good example would be fn match, right? So if I had some files right here and I wanted people to, to search through them or whatever, I want to build a function for it, I could go through here and just say, oh, there you go. And I could search through and find a match for those. So it's a pretty nice tool. There's other things you can do in Python as well that are very DevOps friendly. In particular, I would say archiving is a classic kind of DevOps problem. Let's say you're getting, you want to create yet another offsite backup for, let's say, the database. What you could do is build a tool that uses from shutil import make archive, go ahead and create a username, a root directory, a path, and then you just put in gztar, the root directory, and it would go ahead and create a tard and gzipped archive. So a one-liner, right? Like very, very easy to create archives and snapshots in Python. So this alone is a reason that Python is a strong tool for doing DevOps. And I think it also highlights a little bit of this idea of like, oh, you don't need Python. We have, I don't know, Terraform or something. Like, no, you do, because Terraform, you're not going to be writing custom backup scripts, in that language. It's not even a language. It's essentially a configuration. So I think the most powerful language really is Python, because it allows you to use infrastructure as code and also build custom code. Now let's go ahead and take a look at a presentation. In this case, a walking directory tree. Now this is a classic problem as well that I think is really a good skill for people to have, is that, almost every DevOps skill, engineer, in my opinion, should have it, is you should be able to walk a file system. How do you walk a file system? Well, you would say import OS, say from os.path, import join get size, and you just say for root, dirs, files, and os.walk, go through and just do some things. Every time I'm walking through the file system, do some kind of an operation, like, figure out like what size it is, etc. And if you see a certain directory, skip it. That's kind of the boilerplate, pseudocode. Let's do it for real now. What we would do in this particular scenario is say, here's the hooks to walk a file system. And in this case, I would say import OS from os.path, import join get size for root, dirs, files, and os.walk. Go ahead and print this out. And you can see, it's very intuitive. I have the root directory, I have the directories, and I have the files, and I can actually just walk through and do whatever I want. What are some things that you would do? You could look for duplicate files. You could archive things. You could compress things. You could, find malware. Like, there's all kinds of really cool things you can learn by walking the file system. And I think building this into like a command line tool, or maybe even a web service, these are all great ideas about like how to do DevOps type things with walking the file system. Now, another thing that is super helpful about using Python is it also has this concept of stat, where you can actually get information on a file. And so I can look at the group ID, I can look at the user ID, I can look at what size it is, and all that stuff is from stat. And if we take a look at this and we say, results dot whatever it is I want to find, like creator, like when was this created, right? Dot result dot creator. Does that not work? I don't know why that doesn't work, but basically there's a lot of different things you can get. There you go. It's on the object itself. We have the UID, the GID, the size, the time creation, the modified time, all those creation time. There we go. It's on there. I don't know why that showed up like that. Now, Another tool that is very, very, very common is to pipe out to a subprocess, especially if you're automating things in terms of Unix and Linux. And subprocess.run in particular is a great example. So if I want to do import subprocess, import shell lex, what this does is it has the ability to actually sanitize the input. And this is something that's important to do when you're writing a tool, is to make sure that someone can inject malware or bad commands into your command line tool. And the tool that is going to solve that for you is the shell lex, and it can sanitize the input so people can't do like, drop database, those kinds of commands. And this is a good example of like a subprocess type tool that you can write. Another thing that comes up a lot with using these kind of subprocess tools is maybe you want to do like a health check, right? And here's a good example. You could say import subprocess, import OS, look at a file location. Oh, look, here's my expected, user ID. Go ahead and touch a file. Now verify that the UID expected is actually the UID that appeared. And the reason why this is important is that you could cause problems in production if it's the wrong UID, right? So you want to make sure that the process that's creating files is the appropriate UID. So these would be examples of kind of validation checks that you could do. You could also, even if you wanted to, with subprocess, tap into Linux, which I think is not a bad idea, and do maybe a find command and build your own custom find command. So you kind of use the best of both worlds. Like you use the Linux find command, but then you also use Python and maybe build it into a more sophisticated tool. How would you build a tool like that with subprocess? Here's a good example. Import subprocess, enter a path to search for directories, say with subprocess.popen, do the find, look at the user input, do dash type right here. Go ahead and read the lines and say for line and results, I found this directory. And then finally, go through here and you can do an easy find as well by using Python glob. So there's the subprocess approach, which is you can tap into all of the different things you can do on Linux, which is actually a good approach. Or you can also use native tools, like in this case, glob can do similar things. So I find myself, using both. And here's a good example of glob, right? So if I say, hey, look at the Colab directory sample data here, and I want to look at all the CSV files, look, just one line of code. We print this out. We can say there's 4 results, and I print out the results right here, and I've been able to get that working. So really a huge amount of things that you can do in terms of the file system, in looking at the Python tools and also